the session, so I can post that to you as well, or at least try and share that with you. So, all right. So what I'm going to do is, since nobody's asking any questions, I'm just going to go ahead and show you the first question that was asked, which is how to properly mark the insulin syringe, which I actually did post on there as well in the SharePoint link that's there, and then you can do that. So someone's asking, what is the equation? I don't know what that means. All right, so let me get into and show you how with the insulin syringe. So if you have your packet, or if you're pulling it up now, when you get to it, it's question 15 on how to mark the syringe. And what I'm going to do is I'm just going to draw a mock-up of a syringe and just explain that I believe at this point you have already learned how to properly dispense, or at least do a mixture of insulins, but they ask you to mark a syringe, and there's a specific way they want you to do it. I highly recommend that you confirm with the lab instructor prior to your test next week, to just verify that we're all on the same page. But what I'm going to show you is what the textbooks show and how it's been explained to me. So I'm just giving you that information. So first of all, on question 15, and I'm just going to go ahead and mark that we're doing question 15. On question 15, it tells you to draw up the patients to receive 10 units of regular insulin and 40 units of NPH insulin. Then it asks you to choose syringe A or B. I don't have any other graphics, so the graphic you'll see on the test will be the same selection between the same two syringes. So it'll always be B. Make sure you circle B. And then also, if it is something different, just choose the graph or the picture of the syringe that has the word units clearly defined on it. Units is what you use to measure out insulin and heparin when you get to heparin stuff. So then it says, after you mark the syringe, it says you're going to mark with 2 arrows, and I'll tell you that you probably end up using more than 2, but you want to know the solution and amount to be drawn up first. So you should know that the solution to be drawn up first is regular insulin. And so what I recommend doing is, by the bullet point that says solution and amount to be drawn up first, I would just write out 10 units regular first. That way there's no question when you actually answer this question. And then the second arrow is at the correct total medication level. So what you're going to actually do is, so the total is 40 plus 10. So I'm just going to say there's a mark here at 50 units, okay? And then where you're going to mark regular is actually, because it was drawn up first, hypothetically, it's going to be between 40 and 50. So your regular insulin is actually going to exist in this area here. And again, that's very hypothetical. It doesn't actually, because it all mixes together, but this is what they want you to answer. So essentially you're having an arrow here and an arrow here at 40 and 50, or whatever the numbers are. So I apologize that my arrows look terrible. The rest of this, which they're not asking you to match up, is the NPH. The NPH is the 40 units. But what is important is that you mark your insulin, the regular insulin, closest to the plunger side. So that's important. I promise you my handwriting gets better as I do this. I'm working off of a tablet here, and so my handwriting does improve, just in case you're looking at that. So. Okay, thank you, Julie. Question 20. All right, question 20. And this is good. I was just actually going to ask if you had any questions on like the flow rate questions. So if I'm not mistaken, you didn't really have too much in the way of flow rates last semester. And so with flow rates, you're going to need to know a couple pieces of information. So just write question 20. You need to know that the equation for a drop rate is going to be flow rate times the drop factor. And that's going to equal your drop rate or drip rate. Your flow rate is typically milliliters per hour. Sometimes it's milliliters per minute. Drop factor is always drops per milliliter. And at Allegheny campus, it'll always be given to you. If you're at another campus, they'll usually say a microtubing, and then that would be 60 drops per milliliter, but you may not see that given to you in the question. And then your final, when we measure drops, it's drops per minute. So in order to answer this question, what I need to do is set this up. So milliliters and cc's are the same thing. So it tells me, in case you don't have the packet in front of you, sorry about that. In case you don't have the packet in front of you, it says the physician ordered 1440 cc's of dextrose 5% normal saline to be infused over 12 hours. If your tubing is labeled as below, what will the flow rate be in drops per minute? And then there's a picture of the tubing and it says 10 drops per milliliter. So the way I'm going to write this out is I'm going to say 1440 cc's, which is the same thing as milliliters, over 12 hours. And that ends up being my flow rate. My drop factor is 10 drops per milliliter. And the last step here is I don't want hours, I want minutes. So if I'm going to set this up, I have to do one other conversion, and I'm going to do 1 hour, 60 minutes. One way that this is also done is you could do like a side step here and then just do 60 times 12 and you'll get 720 minutes. And so you could just substitute the 720 minutes for the 12 hours and then you don't have to worry about that last conversion step. So there's no one way to do that, okay? And then your answer will just be the 20 drops per minute. Does that help you, Julie? Yep, you're welcome. Absolutely. And you would do this every single time. If you're somebody who likes to do, what's it called? The ordered over half method, flow rates don't entirely work that way. You could still get it. You might be manipulating the numbers and it might become challenging. So what I'd recommend is that you just follow this formula that says flow rate times drop factor, and then make sure your times in minutes, and you'll be able to answer all flow rate questions.
Can you try question number 14, please?
Absolutely.
I think I have the packet now. That was one that was sent to us. Thank you.
Oh, okay, good. Yes, yeah, I'm glad. They should have sent it to you. Absolutely. So, okay. Okay, so 14, there's actually no math. 14 just says if the patient's blood glucose is 200, how much insulin should you administer? So you're just going to look at the table above and look for the range that says where the 200 lies. So 200 is within the 160 to 220 glucose reading. And so you would just give 2 units. So variations of that is if the patient's blood glucose was 300, you'd give them 6 units. If it was, 380, you'd give them 8 units. And if it's over 400, you would hold the insulin and call the medical doctor. Excuse me. Question 22. Okay. All right. So, go ahead.
It was my question, and my concern is that actually I couldn't understand why I know the answer, but I don't know why they give the left side of this table.
Okay,
We don't
no,
use it.
correct. Nope, you're absolutely right. The reason it's there is because that's what you would see on the drug label. And so they want you to, they wanted you to know, like, they want you to see things that you don't have to use all the information that's presented to you. So that's usually the first thing that I say is when you see that milliliters diluent added, you can just, when you see that area, just eliminate it, cross out that table, because it doesn't mean anything to you as far as being able to solve the equation. You're actually going to see
Okay.
that a couple of times with questions for your semester, third semester, and fourth semester, where you need to be able to navigate what's important and what's not important.
Okay, thank you.
Does anyone want to see the rest of 22 worked out?
Yes.
Okay. Yep, you got it. So with 22, when I work out 22, once we know we ignore the milliliters diluent added, all that tells you is that's how much water, deionized water, that the most likely the pharmacy is going to add to the powder in order to get to the concentration that's listed on the right. So if I add 18.2 milliliters, I'm making more of a dilute solution. If I add 3.2 milliliters, I'm making more of a stronger dilution. And so when the question says use the information below and choose the strongest concentration, you choose the one that has the greatest units per milliliter. So that happens to be the 1 million units per milliliter. And that's how you know which one is the strongest. It's the one that has more units per volume. So all you're going to do then is, once you know that information, you're going to take the 750,000 units. You're going to put that over the 1 million units and times by 1 milliliter. So these are units in case that bothers you not seeing that. And then what you're going to get is, and I always say, because you're going to have a calculator on your test, but sometimes there's a whole lot of zeros here, and it's one of those basic 10-key calculators. So if you have 4 zeros here and 4 zeros here, just eliminate them. 75 over 100 is easier to do, and you'll get 0.75 mil. The reason you leave it at 0.75 is because, according to your rounding rules, a number less than 1, you round to the nearest 100th place. So you don't have to do any rounding. We just stop at the 100th. And a number greater than, or 1 or greater, is going to be to the nearest 10th place. So if this answer was 1.75, then you would round that up to 1.8. All right. The next question was question 4. So in order to answer question 4, you just have to go back. You got to remember, you have to know your basic unit conversions. So you need to know how many teaspoon or how many milliliters are in a teaspoon. So as a refresher, so for question 4, I'm just going to say 1 teaspoon. Oops. We'll just clear that out. For question 4.
Sorry, I meant question 6, not 4. I made a typo.
6. Oh, okay, that's fine. Okay, thank you. Okay, good. So 6 is your input-output question. If you're at a different campus, sometimes this question gets asked a little bit differently. But if you're here at Allegheny, this is how you'll see it. And I'm just going to show you the way that I would recommend setting it up. Basically, what you're doing is comparing, and you're doing, essentially, this is a chemistry type of question where the way that I'm going to kind of explain this, but I'm not going to use all the chemistry terms. So I'm just going to tell you how to start. And if you do what I show you right now, you'll get this question right every single time. They're always going to give you an output volume. The actual output is, in this example, is 500 milliliters. So that's the actual output, how much urine came out. Then you're going to put that over the recommended initial urine output equation, which is the 125 milliliters out. Because in the beginning it says you're going to replace, for every 125 milliliters of urine output, you're going to replace with 40 ml. And so you're putting the original out, or we'll call it, in chemistry, we would say this is the theoretical out, and then the top number is the actual out. If that gave you flashbacks of chemistry and you're like, no, that's okay. That's the extent of chemistry I'm going to tell you. And the reason I'm explaining it this way is because everything is in milliliters, okay? But the difference is it water going in or is it water going out? But the only thing I can really change in this question is I can change the actual out, I can change the theoretical out, and I can change the replacement volume. And then we just manipulate those numbers. As an example, let's say I did the same question, whether it's still 500 milliliters out, but let's say I said it was for every 100 milliliters out, we replace with 70 milliliters. Then I would just rewrite this equation the same way, but instead of 125, it'd be 100 times the 70. So I would set it up exactly the same way. If you did this question, you got this right, and you did like a ratio proportion, I'm going to tell you again, there's no wrong, or there's no one way to answer these questions. So you can do this any number of ways.
So if I'm understanding, the top one you said is the theoretical or the bottom one?
The top one is the actual, like where it says, he said, if urine output for the last 4 hours is 500 milliliters, that's the actual output.
Okay, the bottom is the theoretical, okay.
Right, the theoretical, or you can even identify that as the initial replacement number.
Thank you, sir.
Yeah, you're welcome. One of the challenges is trying to, especially in a virtual sense, trying to share what goes on in my head when I set up these problems and why I'm doing it, so that you, not necessarily so you know why I do it, but so you have an understanding that if you follow this method, it will give you the right answer every single time, and trying to just instill with that. But if you start with the how much output is actual on top versus the replacement number at the bottom, because essentially this is the ordered over half. You ordered 500 milliliters of urine out, and then you have available for your replacement 125 milliliters per 40 ml, and it's just manipulating the numbers. I do not have any other practice tests. I just have the one. So what I always recommend doing, first of all, this practice test will be a mirror of what you'll see next week, meaning it's not exactly the same, but it's close enough. The things that will be different is some of the medication labels may be different, and some of the, but mainly the numbers get changed. That's how it'll differ, but I do not have an additional practice test. All right, question 17. Okay, so this is actually a good one, and I'll give you two scenarios with this one. So we're just gonna, this is question 17. And question 17 states you have a patient that's being tube fed. They're tube feeding 120 milliliters in 90 minutes, and then we want to calculate the flow rate in milliliters per hour. So a way to think about this is, and how this you wrap your head around this, is that you basically are setting it up on a pump, so you're not the one pushing the 120 milliliters in 90 minutes and then sitting there and waiting for it to go through. You just set it up on the pump, and it takes care of it. So there's a couple of ways to answer this question. I'll show you the first way. The first way is you take your 120 milliliters and you're doing a flow rate, right? And this is now over 90 minutes. So it doesn't want milliliters per minute though. It asks for the flow rate in milliliters per hour. So all you gotta do is convert minutes to hours. And when you do that, you'll get 80 ml per hour. The other way to do this is you can also denote 90 minutes as 1.5 hour, and you'll come up with the same answer. Another way, and another thing you might see either on a test or a future practice test is, let's say I had 120 milliliters, and then I wanted that to come out in 30 minutes. Again, you would still do the same conversion if you set it up the way I'm showing you. And then in this instance, you'd actually set the infusion pump to 240 milliliters per hour. Now, sometimes this gets people upset or worked up because they're like, yeah, but I'm not going to actually have 240 milliliters to dispense. Correct. But it would still be going at that rate. You could travel, someplace that's 30 miles away. If you're going 60 miles per hour versus 50 miles per hour, you're going to still cover the same distance. You're just going to, if you're going 60 miles per hour, you're going to get there quicker than the person going 50 miles per hour. It's just a matter of setting the rate, even though you're only covering the same distance. Hopefully that makes sense. Another way is you could just write this as 0.5 hours, and that'll be another way of representing that. Some of you don't like working with decimals, and I don't blame you. So if you don't like working with decimals, all you got to do is convert minutes to hours. Good. Yep. 18. Perfect. So 18 is very similar. And all we're doing is we're saying that we have a 500 milliliter solution, and it's infusing at 125 milliliters per hour. So basically what we're asking here is, when will it be done infusing? So 125 goes into 500 4 times. Sometimes you'll see a variation of this where it'll say, if it started at 8 a.m., when will it finish? Well, if it started at 8 a.m., 4 hours later, it'd be done at noon. If I set something up and it looks strange to you and you prefer it in dimensional analysis, because I kind of go between dimensional analysis and ordered over half, you just let me know if you want to see what it looks like in a dimensional analysis way, and I will make sure that I address that if I write it differently than what you're used to seeing. Okay. All right, so 24, first of all, 24 is very much like 22, in which there's information that is not necessary to answer the question. So 24 says that you have dilantin, 15 milligrams per kilogram loading dose by mouth, then 300 milligrams per day. Then it says specifically for the loading dose, how many milligrams of this anticonvulsant would you administer to a patient who weighs 176? Do you care about the 300 milligrams per day as far as the math component of this question? The answer to that is no. You don't care about the maintenance dose. You care about the loading dose. Yep, I will. So I'll show you this question as a dimensional analysis question. So 24. And what 24 says is we start off with a patient that weighs 176 pounds. So 176 pounds. We don't want pounds, we want kilograms. So we know that 1 pound, we know that 1 kilogram equals 2.2 pounds. So I believe that comes out to 80 kilograms. Does that sound right? Once we know that the patient's weight is 80 kilograms, we then just multiply by the weight-based dose there. That tells me 15 milligrams per kilogram. And you know you've done it right because you can eliminate your variables. And then whatever 80 times 15 is, I believe is 1,200 milligrams. So that's what you would start off with. Or 1,200 milligrams is the same thing as 1.2 grams, but they specifically ask for milligrams, so you do milligrams. Okay, question 16. All right, so 16 is going to be done the same way we did the other drop rate questions. The difference is we don't have to worry about converting our number, or we don't have to worry about converting from hours to minutes. So 16 says we have 75 milliliters infusing over 25 minutes. We have a drop factor set at 15 drops per milliliter. We know we've done everything right because we're left with drops per minute, which is exactly what we want, and we get 45 drops per minute. Sure, you got it, Sherry. Oh, go ahead, Georgina. What's your question?
I find it a little hard sometimes with the way some questions comes. Like when you have a question, I was reviewing some of the textbook. It tells you like when you're going from smaller number to higher, you multiply, something like that, and then from higher to lower. So like if you're going from pound to kilo, you multiply or you divide. That kind of throws me off. Is there any way you can shed a light on those, just in case if we come across questions like that? You know, those kind of metric conversions.
Right. So what I would recommend for, especially with metric conversions, is just practice. So if you like that one question we did, number 24, we had 176 pounds. And then all I did was I set up the conversion factor. Conversion factor is you need to know that 1 pound or 1 kilogram equals 2.2 pounds. So once you know that, you know you want kilograms, you don't want pounds. 1 kilogram is 2.2 pounds, and then you can practice that. But yeah, anytime you go from pounds to kilograms, you divide, and anytime you go from kilograms to pounds, you would multiply. But I have to be honest with you, you're most likely never going to be going from kilograms to pounds because we convert everything into the metric system in medicine. So that would be the only thing for pounds to kilograms. When you're doing, like if you're going from milligrams to micrograms,
Exactly.
or grams, you just need to practice it. So what I would recommend you do is like those first few questions 1 through 4 are practice questions for those. And then, yeah, just practice those and then make sure you're getting them right every single time. And then there might be more questions in that link that I sent you where there's, if you look at some of the other tests, all the tests start off with the first 4 or 5 questions are the basic unit conversions. So just practice them.
Okay, thank you.
You're welcome. All right, question 11. So question 11, let me get to that, is first of all, anytime you see something that tells you to circle the correct amount or mark the cup or mark the tube X, please, please, please remember to mark it. That's one of the things that gets wrong on these, or what students get wrong on these tests is not the math. It's just not following the directions where they asked you to mark different things. So it says we have 75 milligrams Demerol, and we want to convert that to milliliters. So how many milliliters would you give per dose? and they tell you that the available for Demerol, and then it's the generic of Demerol, is 50 milligrams per milliliter. So what you're going to do, oh, okay, yeah. So you would mark it as 1.5, and you would answer it as 1.5 if that's what you got, if that's the issue there. And you would just circle the 1.5. On that question, normally, because it's written down there, they want you to most likely write it as 1.5. But in reality, there's, I mean, there are definitely preferred ways. It just depends on, honestly depends on the instructor. But if you were going to write it out, your answer, I would say, because it's written down below, I would just write it as 1.5 milliliters. But you're not wrong if you say the 1.5. I'm just advising that because that's how it's listed on the Tubex. Yeah, it's the same answer. 1.5 is the same thing as 1.5. Typically for tablets, you're going to write the 1.5. So if you're going to dispense tablets, it'd be like this. And then obviously you can see like these are 2 milliliter solutions that are going to be, that could be written differently. So like if you looked at, let me just find another example. I know there's should be something. I don't have another example, I'm sorry. But sometimes you'll see that written out as a decimal answer. So that's the reason why I left it as a decimal, because in most certain circumstances, when you see a volume, it'll be represented as a decimal. With tablets, they want you to do the half sign. So that's why the answer key, Sherry, for number 11 is 1.5. But it's, like I said, it wasn't meant to be confusing. So I do apologize if that threw you through a loop. Or a loop, however you say that saying. You're welcome. Any other questions? All right, well, since it was asked already earlier, I'll just, I just want to give some sample. These are just off the cuff examples for some of the things you might see as far as basic unit conversions. So typically when I ask these questions, and I'm the one who writes the test, so I don't think they would have changed these up too much. I usually only focus on going from milligrams to grams, grams to milligrams, milligrams to micrograms, micrograms to milligrams. So you will not have a question, or you shouldn't have a question that goes from micrograms all the way up to grams, just because that's not how it would look in reality. So I try to keep it consistent where you would actually see this done in like a real world situation. So like the first question is just going from milligrams to grams. But let's say we turn that around and I said I wanted to know, I wanted to go from 75 milligrams and I wanted to go to micrograms. So the way I would write that out is I start off with what is given to me. Then I'm going to create a conversion. Okay. So micrograms, there are 1,000 micrograms in 1 milligram. Okay. And then that's how I know whether or not to multiply or divide. If you're very good at this stuff, and like I think what Georgina was saying is, you can, when to multiply or divide when you go from bigger to small. Yes. Like when I look at this, I don't go through this process of dimensional analysis, When I go, I know that milligrams is a bigger unit than micrograms. And so when I go I set this up. I apologize. Let me change these things here because I set this up wrong. When I go from, because I wrote down the wrong unit here. When I go from milligrams to micrograms, I know that that number is going to be much bigger, okay? Because there are 1,000 micrograms for every milligram. So what I would do is I would take that 75. This is my process. I know there's a decimal here, and I would move it 1, 2, 3 places, and then I would have 75,000 micrograms, okay? In the original setup where it told you 75 milligrams to grams, I know that there are that grams is a bigger unit, but there are 1,000 milligrams in a gram. And so the way I would do that is I would start with my same decimal point, but now I'd move it over 3 places. And so 0.075 grams would be that. And like I said, that comes with practice. If you don't feel comfortable doing that, then write out your conversions. 75 milligrams. I don't want milligrams, I want grams. There's 1,000 milligrams in 1 gram. If you hear how I'm asking myself those questions, I'm doing that on purpose so that you hear me saying, okay, I don't want milligrams, I want grams. I don't want milligrams, I want micrograms. And that's how you set that up. And that's kind of the conversation you have with yourself. If you ever get stuck and not sure where things go, that's how you practice that. And if you already know, then you know. Then I'm not here to stop you from doing the right way.
So most likely, are we gonna get things like all these grain going from the smaller equivalents of grains like the GR?
Nope.
Okay, those kind of questions are not gonna pop up.
Nope. Your test will look very similar to the practice test that I gave you. And
Okay.
don't do the apothecary units anymore. So they
Okay.
used to do that, but it's probably been 10 years since they've had questions like that. And you shouldn't see apothecary units on NCLEX either, because they don't use apothecary units in at least in that. So the only time they use like grains and drams, like drams is used for perfumes and grains are used for other things. So yeah, you shouldn't see that.
Are we gonna be
I will not
anticipating stuff like inches and feet?
Nope.
Okay.
Because everything in nursing is metric system. So.
Okay. Thank you, Mr. David. You're shedding more light. Thank you. So,
Yeah, no, you're welcome. And like I said, I can tell you with confidence because I wrote your tests, and then all I did was after I wrote the test, I made practice tests from those tests. So that's how I know that they look very similar. And I can tell you based off of the blueprint that the nursing department has set up for you guys that there are no questions on apothecary units, and there's nothing like you don't need to calculate skin surface areas or anything like that. You might need to do that later on in one of your units, but it's not something you need to worry about for drug calc.
okay. Oh, thank you very much.
Yeah, you're welcome. Sure. So question 2. Question 2 just says, hold on. we just going to do a conversion of micrograms to milligrams. So I already gave you an example of that. So if you're doing this the straightforward way, you just move the decimal 3 to the left and your answer is 0.125. But for practice purposes, if I have 125 micrograms, but I want milligrams, again, I ask my question. I don't want micrograms. What do I want? Milligrams. When do we want it? Now. 1,001. We know we've done it right because we can eliminate micrograms, and you have 0.125 milligrams. Now, what's important is notice that I'm not rounding these numbers. Do not round basic conversions, okay? You do not round to the nearest 10th or 100th with basic conversions. That's the, if you go from pounds to kilograms, you can round to the nearest 10th, but when you're going from micrograms to milligrams or milligrams to micrograms or milliliters to liters or anything like that, do not round. And it says that in the, beginning of the packet. All right, 25. So 25 is a good practice for doing a conversion of units because it tells you the order is 500 micrograms and then what you have available is 0.05 milligrams per milliliter. So the trick here is we cannot measure or we cannot do math between different units. We need them both to be milligrams or both to be micrograms, and you get to decide which is which. So I'm going to go ahead and just do, because for me, it's just a little bit simpler. So with 25, I'm going to convert the 500 micrograms to milligrams. So I'll set this up, 1 milligram, 1,000 micrograms, and I get 0.5 milligrams. Now that I have that, now I can do my math. And all it is like you did any of the other unit conversion questions where you're dispensing out your volumes. So I don't want milligrams, I want milliliters. I have 0.05 for every 1 milliliter. And I believe the answer to this is 10 milliliters. You could have also done this by converting the milligrams to micrograms. So just as an added practice, if I take 0.05 milligrams and I want to convert that to micrograms, so I don't want milligrams, I want micrograms, 1,000 micrograms for every milligram, and I would get 50 micrograms. Now I would plug it into the same setup here, but I would not change the original order. So I would say 500 micrograms, and then I'm just going to show you the alternative way, over 50 micrograms times the 1 milliliter, and we still get the same answer, 10 milliliters. So like I said, there's a variety of different ways. You may prefer to make numbers bigger because you don't want to deal with decimals, and I'm right there with you. Did everyone get 23 okay? Yep, I can. Okay, so let's go ahead and do 23. So you most likely you can do 23. It's just that it's just a different variation of the question. Basically, what you're doing is you're calculating the milliliters of the visceral, you're calculating the milliliters of the meperidine, and then you just add them together. So basically, it's almost like you're creating two doses in the same injection. So for the visceral, it says we have 60 milligrams. And then we need to figure out how many milliliters to administer from that. So what I have is 50 milligrams per milliliter. So when you set that up, you get, is it 1.2 milliliters? I'm just going to write that down and someone will correct me if that's not it. So that's for the visceral. Then I would do the same thing for the meperidine, where it says 85 milligrams. $85 milligrams, and then I'm going to take what is on the label of 75 milligrams per milliliter, and I believe that's 1.133333, something along those lines. And so what you would do is, this is an example where you would just round to the nearest tenth. So since this is 333 repeating, we can just eliminate it. It doesn't affect the 1. So we just leave it alone. That's milliliters. So I just take the 1.2 plus the 1.1, and I get an answer of 2.3 milliliters. And again, if you're somebody who likes to do desired or the order over half, you're welcome. You would just write this as 60 over 50 times 1 to get your 1.2. And then you would write the 85 over 75 times 1 to get your 1.1333 repeating milliliters. All right. Well, if there's no other questions, I'm doing your section for Nursing 130 again this afternoon at 3:45. So you're welcome to jump on that if you'd like. Technically, you can jump in on any of the sessions. Just know that I'll when I get to the 220, 230, and the 240 sections, I'll be doing a heparin protocol most likely. But if you have questions, you're welcome to send those out. So.
I'm sorry, can you repeat that? Did you say you're doing this tomorrow?
No. Today is the last day for the reviews. I did them on Tuesday and then today. So at 3:45 this afternoon I'll have another session for 1:30.
Okay, thank you.
You're welcome.
I was asking, can we bring questions outside the packet, or does it have
You
to be?
can, but if I tell you that it's not, that you don't need to worry about it, then I probably just won't work it out.
Okay.
And then you can always email those to me as well, Georgina, and
Okay.
I will be happy to answer them for you.
Thank you.
Yeah, you're welcome. But if you have other questions that are outside of the packet, by all means, like, share them. And the worst case scenario is I'll just tell you, like, oh, you don't need to worry about that, and let me see if there's any other questions before I get into it.
Okay.
All right. Well, I'm going to go ahead and you're welcome. I'm going to go ahead and close out of this. And like I said, if you have any, if you want to come back in at the 3:45 time, that's specifically for the 1:30 students. Or if you have any questions, email me, or you can go onto my YouTube. And if I don't hear from you, good luck on your tests.
Thank you once again.
Yeah, you're welcome.
Hi, I have a question.
Yeah.
Are you able to email this recording to us? Or how
I
can
will
get
have I will most likely, or if you email me, I'll reply back with that. Yes.
Okay, cool. Thank you.
You're welcome.
Bye-bye.